Okay, now this is the 2022 question 15 of the HKDSE paper 2. To be able to do this question, you should be very familiar with the formulas. Okay, so in this case, they told you the radius of the solid hemisphere and then the base radius of a solid circular cylinder are equal. So because they are different radiuses, I'll name them as radius of hemisphere, RH, and the radius of the cylinder. And they told us that they are equal. So RH equal to RC. And they also told us that the height of the cylinder, so height of the cylinder, HC, it is equal to its base diameter. So it's equal to the diameter of the cylinder. But we should be also aware that diameter simply means there's two radiuses, because a complete diameter consists of two radiuses on both sides. So it's actually equal to 2 times of the cylinder's radius. So with that all done, they told us then to find the ratio, so ratio of the total surface area of a hemisphere and the total surface area of a circular cylinder. So if we talk about a hemisphere, we got 2 pi r square on the top, and then a flat surface of a circle, so hence is a pi r square. So hence in total, so the total surface area is 3 pi r square, and this is a hemisphere, so radius of h. Okay, and then on the other side we have a cylinder. So in a cylinder we have a curved part, which is 2 pi r h, and then we got 2 complete circles, 2 pi r square. So we got 2 pi r h, because these are cylinder, so we put them RC, HC, and 2 pi r squared. So that's what we're gonna come up with, because that's the formulas of the total surface areas of the hemisphere and the circular cylinder respectively. Now, when we want to make the ratio, so we should end up with just numbers. So that means that we need to make every radius and the heights become one single term. Okay, and that's what we're gonna be done with, is the relationships that we actually got earlier. We know the RH is equal to RC, and HC is also in terms of RC, so everything would be then converted to RC, radius of the cylinder. So because the radius of the hemisphere is the same as the radius of the cylinder, so we're gonna change the radius of the hemisphere to the radius of the cylinder. So this is one change we've done because of this relationship. And then on the other hand, we know the height of the cylinder is equal to 2 times of the radius of the cylinder, and we got 2 pi r cylinder. So now you can see everything is in terms of RC. So we got 3 pi RC square equals to, so we have to do some maths here. It's 2 times 2, it's 4 pi RC squared, and then we got 2 pi RC squared. And hence, because they are both pi RC square, we have 6 pi RC square and then 3 pi RC square. And now finally we can simplify it into the simplest form. Well, they both have, good news is they both have pi RC square, so that can be simplified. And also we can simplify the 6 and the 3, so the final answer would then turn to 1 to 2 ratio. Okay, so the answer is A.